Alright, now if we take out the extern and actually give this guy a definition, then we'll see that we will get an error. Since both of these cfile.c and main.c both include cfile.h, and like I told you before, it's almost like you're copying and pasting what's in here into there. It would be like copying and pasting this and here and here. And that would give you a redefinition error, because you have the same variable with the same name, and the linker is going to see that and be like, these two variables have the same name, why are they being created twice? And it's going to give you an error, and we'll see that right here. So yep, indeed we see it's a linker error, once again because of the LD, and we're getting a multiple definition of my global variable, because it's just like we're copying and pasting the same thing in two places. So how do we combat this? So one way to do that is to use something that we just learned, which is the keyword static. So let's just run it, see what happens. And it sees it, as you see, it lets us compile now. And that's because what static does is, like I said before, it makes this variable private, or it can only be seen within this translation unit. So what this is effectively doing is, so like I said, we're just like copying and pasting. So what this is effectively doing is it's making a static int my global variable equals 2 here, and it's doing the same thing here. And what that does is it basically creates two separate instances of the same variable with the same name, with the same value to start out with, but they're not stored in the same place in memory. One can only be seen by this guy. So if I did something like my global variable equals 3 here, this only affects this my global variable. This my global variable is still 2, and that's because of static. So let's try show you off a use case, show you off an example of that. So we put static int my global variable equals 2. So then we're gonna print it. Here we'll change it here. Set it equal to 3, and then we'll print it. Say the global variable is blah blah blah, and then in our print function, let's just print. Let's just make this return 0, and let's leave 1.7. Okay. Let's make a print function called, say, and print var void, and this void. And all this function is going to do is just going to be a public function that just prints out the same exact thing as this. So let's copy this and paste it here. And then let's call that function. That's going to be called print global variable. So here in this translation unit, we changed my global variable to 3. But when we call this function, it's going to be looking at this global variable, the global variable for this translation unit. So that should be 2. So if we run this, you see it prints 3 and then it prints 2. That's just as I said before, it's because we have two separate instances of this global variable. To further prove this, let's just print the address of the global variable. So we're printing a pointer. We're going to take the address of that. Do the same thing over here. And let's see what we get. And as you see, the first one has an address that is not the same as the second one. If we change this to non-static, and since we can't have a redefinition, I just make this like that. bam, then compile and run, you can see that they have the exact same address, and that's because it's a global variable with the same name, and that's the same for if we use extern here too. And this right now won't compile as it is because we'll probably get a linker error that says there's no definition of my global variable. Yep, and we do. So we just need to have this defined somewhere because, as you know, extern means that this exists, but it's not defined here. And linker is, the compiler sees it and it's like, oh yeah, that's fine. The linker will take care of wherever this is defined. And then the linker sees, oh, this isn't defined anywhere. So we need to show the linker where it is. You run that and you see they're the exact same address. So static is what will make them different. Okay, now there's one more keyword I wanted to go over, one more qualifier and see, and that's the volatile keyword. And this is especially important for embedded programming because this is what you need when you're working with interrupt handlers and stuff like that. So we use volatile for our variables. So we make a volatile int my variable equals 3. So the actual definition for what volatile does for the C language, I'm pretty sure, is that it's compiler defined. So this is most used, I've only seen it used in embedded systems in which the compilers define volatile to be a keyword that says do not optimize this variable. So what you write here is not, like the code you write here is not necessarily what is taken as what is compiled and then linked and then what is essentially run. This isn't exactly what will happen because there's different optimization levels that the compiler might take where it might say, you don't use this variable ever, why, what is the point of even assigning memory for this? So let's just not assign any memory for this variable at all. So this becomes pertinent for interrupt handlers. So this might not make that much sense if you're not familiar with like interrupts and how they work. But basically, they're a function that gets called by hardware, not the software. So nowhere in my code am I going to be doing interrupt handler. I'm not going to be doing that. That's because this interrupt handler is basically stored somewhere in memory that is called when a certain thing happens. Like I might receive some data and then this function gets called. So say in your interrupt handler you wanted to increment my variable. So you did my variable plus plus. And then you wanted to print that variable in your mainnet. My variable is %d. And then yeah. So you wanted to print it here. And in an embedded system, you would have something like this. Infinite loop. Yeah. So anyways, the compiler might see, oh wow. Oh, let's pretend we didn't have volatile for a second. So the compiler might see, oh wow, this variable is only changed in the interrupt handler. And an interrupt handler is never called. It's never called anywhere. Because it can't see that the hardware is going to be the one that's calling it. So it goes and it says, okay, let's make some optimizations. It's because this variable never changes, so let's just make it const. So the compiler might be like, this can be a const, and it can be stored in read-only memory because it never changes in the code that's actually run. So then you're going to have a problem when your interrupt handler is eventually called by hardware and it tries to modify read-only memory. It might give you an error. It might just not do anything. And then your program doesn't work the way you want it to. So in order to work around this, we use volatile, which is compiler defined by many of the compilers used in embedded systems, the tool chains, to basically say don't optimize this. So the compiler's going to see this and it's going to be like, I'm not going to optimize away this variable, even though it's never changed. I'm not going to do anything to it. It will stay in RAM or wherever system memory, and it's able to be changed. So then when your interrupt handler does get called by hardware, because it will get called if your system is set up like that, then my variable will able to be changed. So that's like the importance of volatile. You usually only ever want to use it if this variable is only being changed in, let's say, your interrupt handler, something like that. Only changed or only accessed in the interrupt handler. Because it might even do one more thing. Say in your interrupt handler you don't change it. Say this is the only place you actually access it. Nowhere else do you access it. The compiler might go, if there's no volatile, the compiler might go, oh, okay, this variable is not used anywhere, so let's just get rid of it whatsoever. And then when you go to print it inside your interrupt handler, then it's gonna not be able to print anything because that doesn't exist. So you might get an error or something like that. So that's why I use volatile. And I'm sure Nate or somebody else will go over that when they talk about their embedded systems lecture. Alright, and so that's all I have for now on C stuff. If there's anything else you want me to talk about, please let me know with regards to C. But for my next lecture, it's going to be on C++ and basics of that. So thank you.